All right, all right. So this afternoon, uh, you are seeing a new face for the first time, perhaps in your class. Mr. Chrome
Hopefully.
will not be here to take you through this lesson. So I'm stepping in for Mr. Chrome, your usual geography tutor. All right. So basically, this afternoon, what I'll be taking you through is weathering. We shall be dealing with the topic weathering for today. Okay. Okay. So in the course of this lesson, if you're not clear with a particular point, perhaps you want me to re-emphasize a point, you are at liberty to do so. Just raise up your hand, and then that will notify me, and then I'll give you the opportunity to do so. Okay. All right. So this is not different from your usual classroom setting. So kindly behave so that we can have a smooth lesson. Okay. Minimize the noise at the background. All right. So I think we can begin now. So I hope you know me. Yeah, Mr. Abraham Atsu. All right. So let's go through the lesson overview for today. As I told you earlier, we are dealing with the topic weathering. Weathering, that is the topic I'm going to start with you for today. So let's look at the lesson overview. What are we hoping to come across in the course of the lesson? Or what are some of the concepts that we should be meeting once we delve into this lesson? So first of all, we are going to look at the definition of weathering. Then we shall also consider the factors that affect weathering. And then finally, the types of weathering. Okay. All right. What are our learning objectives? What are our learning objectives? What are we hoping to achieve by the end of this lesson? So we have three objectives here. We have three objectives here. The first one is that you'll be able to define weathering. At the end of this lesson, you should be able to define weathering comprehensively. Then again, you should also be able to identify the factors that affect weathering. Very, very important. Okay. You should be able to identify the factors that affect weathering. Then finally, you should be able to distinguish between the different types of weathering. You should be able to differentiate between the various or the different types of weathering. All right. So let's proceed and look at the definition of weathering. The definition of weathering. Perhaps I believe over these few days you've been home. I believe you are not just eating and sleeping. I'm optimistic that at least you've gone through your geographic textbooks. So who is familiar with this term, weathering? Any idea? Any of you have any idea concerning the definition of weathering? Just if you have the idea, just unmute yourself and then tell us. Okay. Can any of you define weathering? Can you all hear me? Hello? Hello? Can you all hear me? Let me know if you can all hear me. Yes, yes, hello.
Hello.
Yes, are you guys with me?
Okay, yeah, we are with you.
Yes, so I'm asking, please and please, please and please try and minimize the noise at the background. The feedback is very, very terrible. All right, so the question I was asking, any of you, do you have any idea of about the definition of weathering? Do you guys have any idea? Who can give it a try? You don't have any idea? Emmanuel, are you there?
So I'm there.
Can you give me a try?
The gradual breakdown of rocks into smaller particles.
Okay, so Emmanuel is saying the gradual breakdown of rocks into smaller particles. That is his view about the definition of weathering. Yes, anyone else? Anyone else? All right. So let's continue. All right. So by the definition, we refer to weathering as the physical disintegration. Okay. Weathering refers to the physical disintegration or breakup and the chemical decomposition of rocks in situ. Okay. The physical disintegration or breakup and the chemical decomposition of rocks in situ. Okay, the situ there, you can see the situ there is being underlined. It is very, very crucial. It is very, very important. Okay, what it means here is that once the rocks are broken into smaller pieces, or once the rock is disintegrated, okay, once it's broken into smaller pieces, the particles, the remains, okay, are at the same place. They are left at the place where they are being weathered or where they break up. Okay, they are not moved to a different location. So the particles remain at the same place. That is what that term situ means. Okay, all right. Then we can also refer to weathering as the gradual, okay, the gradual disintegration of rocks in situ by physical, mechanical, chemical, and biological processes. Okay, so the focus here is on the term gradual, bit by bit break up. Okay, bit by bit disintegration of rocks at the same place. That is why the situ is there. Okay, and this can occur physically or mechanically. Then it can take a chemical reaction. It can be in the form of a chemical reaction. Then we have the biological processes. Now, in some literature or in some textbooks, you are likely to come across some writers or tutors trying to combine the biological processes and then the physical, the mechanical as one. Okay, so there's no much issue about that. Okay, because the biological process, okay, involved in the breakup of these rocks, okay, are sometimes physical or mechanical in nature. That is why it is being attached as one. Okay, all right. So let's continue. I believe you are clear with the definition of weathering. Okay, I believe you are clear with the definition of weathering. The first important thing that you have to know is the breakup of rocks. Okay, the breakup of rocks, the disintegration of rocks. And this breakup or this disintegration can be physical, whereby it will manifest for you to see that, okay, actually the breakup or the breaking up of the rock has actually manifested. So you can see it. Then the chemical process is hard to view with your physical eye, okay, whereby chemical reaction is taking place. Sometimes you can't notice it. That is why we refer to that as a chemical reaction or a chemical process. Now, you have to focus on the term we use here, the situ. The situ here is very, very important, okay? It is very, very important to mean that once these rocks or the bedrock is being broken or is broken into smaller pieces, the fragments or the remains of the broken rock are not moved away from where they are being disintegrated. Okay, they remain at the same place where the breakup has occurred. So please, you have to take notes. Okay. All right. If you have any question, you are not clear, perhaps you want me to re-emphasize a point, just give me a hand up, and then I'll give you the opportunity. Okay. All right. So what are some of the factors that affect weathering? What are some of the factors that affect weathering? Okay. What we mean here basically is that what are some of the factors that has a propensity to speed up, okay, the rate of weathering, or what are some of the factors that will determine a particular, okay, type of weathering taking place in a particular geographical region. So that is what we are basically going to look at. Is that clear? And these are the factors that can affect weathering. All right, so look at the first one. We have 4 of them here. We have 4 of them here. So I'll take them one after the other, and then we'll see how these factors can affect weathering. We'll see how these factors can affect weathering. Okay? All right, so we can continue. The first one is climate. The first one is climate. 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 Now, have you guys done elements of climate perhaps in your subsequent terms, your previous terms?
Yes, we did it.
You did it, right? All right, so what are the elements of climate?
Humidity,
Pardon? I can
humidity,
hear,
rainfall,
yeah, I can hear humidity, I can hear rainfall. Is that all?
sunshine,
Uh-huh.
yeah.
Well, are you there? Pearl, are you there?
Yes, sir. Yes, sir.
Yes, can you give me one element of climate? Your colleagues have
We have,
confirmed you have been taught. So can you give me one?
we have atmospheric temperature or pressure.
Atmospheric moisture, that is correct. That is the same as the humidity. Okay. That is same as humidity. Okay. Okay. All right. Then one important element of climate that you need to know, okay, has to do with temperature. Okay. Temperature. Very, very important. Okay. Very, very important. So climate, how can climate, okay, as a factor determine or affect weathering in a particular area or in a particular region? How can climate as a factor affect, okay, the weathering of rocks in a particular region or area? Yes, who can try? Who can try? All right. So when we are talking about climate, okay, as you've rightly mentioned, the various elements of climate, temperature, okay. So in areas where you have high temperature, in areas of the world that you have high temperature, temperature ranging from between 36 degrees Celsius to somewhere 45, 48, 50. Okay, these regions are noted to have high temperatures. Okay, so in areas such as perhaps the desert areas or the arid regions, okay, then these areas can support what we call physical or mechanical weathering because of the rise in temperature, the temperature changes. Okay. So when the temperature as an element of climate that we are considering is very high in a particular region, then it has the potential to spearhead or to fast track a particular type of weathering, which we are referring to as the physical or the mechanical weathering. Is that okay? Then you may also want to consider humidity and then perhaps rainfall, water. Okay, we all know. Uh, Perhaps you should bring a little knowledge in interscience. Okay, when a chemical reaction is taking place, when ions try to dissolve each other, you have ions dissolving here and there. You know, the role of water is very, very important. Okay. So when you have, when you find yourself in a region whereby water, okay, there's a lot of atmospheric moisture within in the environment, there is high rainfall, then perhaps you are likely to have what we call chemical reaction taking place because of the water availability. Is that okay? Is that okay? All right. Then let's consider the second
Yes,
factor.
okay.
Let's consider the second factor that can affect weathering. Okay. Let's consider the second factor, the type of rocks or the type of rock. The type of rock as a factor that can determine, okay, the type of weathering or the rates at which weathering will take place in a particular geographic location. All right. I believe you've done rocks.
Yes, we've done it already.
Okay. Okay. So what are the various types of rocks that we have?
Metamorphic, sedimentary, igneous.
Okay, so we have igneous rocks, we have metamorphic rocks, and then we have sedimentary rocks. All right. Now, the type of rock is very, very, very important. Okay, the type of rock. Now, perhaps in the study of your rocks, you are aware rocks differ in terms of their chemical composition, right? Rocks also differ in terms of their texture. Okay. And then rocks also, hey. Okay, and then you are aware rocks also differ in terms of their permeability. Okay, their permeability, their texture, their chemical composition. So all these factors has come into play when we are looking at the type of rock. All right. So rocks that are hard, okay, rocks that are hard, rocks that are relatively hard are resistant, okay, to what? Weathering. Rocks that are hard are resistant to what? To weathering. What it means here is that normally those rocks that share this feature or exhibit uh, the feature of being hard, being solid, are not easily broken up. Okay, they cannot be broken up easily. They cannot be easily disintegrated. That is what it means. Is that okay? But then uh, uh, the rocks that are soft, okay, comparatively, relatively, the rocks that are soft can easily be broken compared to those that are hard. Okay, so you take metamorphic and then igneous rocks. Okay, an example of an igneous rock is a granite. We take granite as an example. And then you take a sedimentary rock. Who can give me an example of a sedimentary rock? Who can give me an example of a sedimentary rock? Is sandstone an example of a sedimentary rock? Is sandstone an example of a sedimentary rock? Emmanuel, are you there?
Yes, I'm there.
I've asked a question. Did you hear the question?
Sandstone.
Yes.
Yeah, it's an example of a sedimentary rock.
Okay. So let's take an igneous rocks. Let's take an igneous rock like granite. Okay. And then a sedimentary rock like sandstone. Which of these two rocks do you think will be easily broken? Which of these two rocks do you think will be easily disintegrated?
The sandstone will be easily disintegrated.
Okay, so sandstone will be easily disintegrated. Why do you think so? Why do you think so?
Because igneous rock is made up of molten magma, which is usually hard.
Okay.
So igneous rock is harder than sedimentary rock, and sedimentary rock is one of the softest rock.
Okay, so that is good. That is good. So the type of rock, okay, is very, very important. It's very, very, very crucial. Okay, it has a role to play, or it helps to determine the rate of weathering and then the particular type of weathering that is likely to occur. So what are we basically saying here? Okay, the harder the rock, okay, the harder the rock, okay, the less likely it is to be broken or disintegrated. I'll take that again. The harder the rock, the less likely it is to be broken or disintegrated. On the other way around, the softer the rock, okay, then the more likely it is to be broken or disintegrated. So let's take note. Is that okay? All right.
Yes, sir.
All right. Then let's go to the third factor. Okay, let's go to the third factor, which has to do with the relief or topography. The relief or topography. What comes to mind when we mention relief or topography? What comes to mind? What comes to mind when we mention relief or topography? Ken, are you there?
Okay, when we talk about yes, sir.
Yes, I can hear you. Ken, I can hear you. I'm asking what comes to mind when we hear relief or topography.
I said when we talk about relief,
Or topography, what comes to mind? What do we mean?
sir,
Yes.
when we talk about relief, examples of relief can be
Yes. Who is speaking? Is it Emmanuel? Who is speaking? If you are speaking, let me know your name before you answer. Okay.
sir, it's Emmanuel speaking.
Okay. So yeah. Okay. So answer the question.
I said examples of relief can be rainfall, agriculture, and
Relief.
I'm
Relief.
not sure. Yes,
You're not so sure.
yes, sir.
All right. All right. That is okay. That is okay. Now, basically, when we are talking about relief or topography, okay, the first thing that should come to your mind has to do with highlands and lowlands. Okay. Okay.
Okay,
Yeah, highlands and then lowlands. Okay, highlands and
okay,
lowlands. Okay, how the landscape is being shaped. All right. Now, how can relief or topography as a factor, okay, affect the rate of weathering or determine a particular type of weathering? All right. Now, we know that on mountain tops, okay, on the top of mountains, the temperature there is relatively lower than the surrounding environment. Correct?
yes, sir.
Yeah. So as a result, as the result of the colder temperatures that are prevalent in high mountains, okay, on top of high mountains, this has the potential to support what we call activities of frost action. Frost action. Basically, frost action here means that you have water as a result of low temperature, water accumulates within a particular rock, and then as a result of relatively lower temperature falling drastically causes the water to freeze. Okay. And then maybe
Yes, sir.
perhaps as time goes on, when there's an increase in temperature, then this same situation will cause the water which which was frozen, okay, to begin to melt. So this is the frost action basically that you are talking about. We'll come to that briefly, but then I just want you to have just a fair idea about what we are talking about. Okay.
Yes,
All right.
sir.
So on top of high mountains, we have the probability of a weathering, a physical or mechanical weathering taking place, which is the frost action. Okay. Then when we have areas
Okay.
of lowlands, okay, a low-lying area whereby temperature is sometimes uniform, then we may have perhaps a chemical weathering taking place. We may have perhaps chemical weathering taking place. All right. Now let's look at the final factor, the last factor, the last but not least, okay, factor that can affect weathering. That has to do with the action of living organisms. The action of living organisms. What are we basically referring to? We are referring to the activities of plants and animals, okay? We are referring to the activities of plants and animals. All right. So so there's a question there. How can the action of living organisms as a factor affect weathering? So that is a question of thought. Let's ponder over it and see the way forward.
Yeah, she's around.
All right. So the action of living organisms, plants and animals. How can the action of living organisms as a factor affect weathering? That is the question I'm asking. If you want to try, just raise up your hand. I'll see you and then I'll let you in. Okay. Okay, Emmanuel, I can see your hand up. Yes, so unmute yourself and then give it a try. Emmanuel, Fumado, I can see your hand up. So just unmute yourself and then give it a try.
Places where there are plants and animals, usually weathering does not occur. But where there is no plants and animals, like the rocky areas where animals don't have pasture over there, usually the breakdown of rocks.
Okay. You've tried. So that is okay. Can we hear any other view, any other opinion? Yes, any other idea? Now, okay, so mute yourself. Emmanuel, mute yourself. All right, that's good. So let's first consider the action the action of plants. Okay, let's first consider the action of plants. Now, in areas where we have thick, vegetation cover, thick. Who is that? Mute yourself. Who is that? Mute yourself. All right. So let's first consider the action of plants. Okay. In regions or areas where we have thick vegetation cover, okay, what it means is that perhaps the vegetation cover is serving as a shade, okay, as a protective, okay, mechanism for the surface rock to be exposed, okay, to the undying conditions that can lead the rock to break up. So thick vegetation cover does not support physical or mechanical weathering. Okay, perhaps we could have chemical, chemical weathering taking place, whereby we have the composition of maybe plant leaves. Okay, so where we have a thick vegetation cover, we are not likely to experience what we call the physical or the mechanical weathering, but perhaps it can support what we call the chemical weathering. Then also, uh, um, the roots, the roots of plants. The roots of plants can also play a major role, to determine the rate of weathering. So when you have a tiny crack, when you have a tiny track developed, within the rock bed or within the bedrock, and then a root of a plant finds its way into what? That crack. Once the tree or the plant grows, the root also grows, or expands, and this also tends to what? To widen, to widen the crack within the bedrock, and this can cause the rock to break easily. Is that okay? The same applies to the animals. Okay, we have the rodents that can bore hole into rocks, exposing the rock to further break up. Is that okay? Can we consider the activities of human beings? Okay, the activities of men, or the activities of man. Can you think of any activity that we engage on or we engage in that has the potential to influence or fast track the rate of weathering or determine a particular type of weathering in a particular area or region? Can you mention any human activities that we engage in that is likely to affect, the rate of weathering or determine the type of weathering? Yes, who wants to answer? Who is answering? Let me see your hand up first. Who is answering? Let me see your hand up first.
Hello, sir.
Yeah, Pearl.
Yes, sir.
Yeah, you want to try?
Yeah.
Okay, yes. So what are the activities that we engage in?
I think of mining.
Mining, that is good. That is good.
Hello.
Mining, yes. You mentioned mining, right?
Yes, sir.
Yeah, that is good. That is good. That is one. That is correct. Any other activity? Is it only mining? Is it only mining? What of road? Okay, okay, good. Emmanuel, I see your hand up. Yes.
Drilling.
Drilling.
Yeah, drilling.
Okay, okay, okay. I'll take that. I'll take that. Drilling, yes. Is that all? What is the difference between mining and quarrying? What is the difference between mining and quarrying?
Okay, mining means where digging large, digging a particular place of a land or digging a particular portion of a land to extract minerals.
Okay,
Whilst quarrying is a breaking down of rocks by using chemicals or using properties to break down huge rocks into smaller rocks.
okay, okay, okay. So that is good. That is okay. All right. So I think we are all on course. Um, so I wanted to chip in one that has to do with road construction. Road construction. Road construction. Who can try? How can road construction affect weathering? Okay. How can road construction help to spearhead or fast track the rate of weathering in a particular region? Um, have you all been to Kwewu before?
No, sir.
Any of you ever been to Kwewu? Any of you,
No, sir.
ever used Hohoi road, whereby you have to fly through Biatba area, yeah, to Hohoi. Okay, so basically what we are saying here is that sometimes due to road construction, okay, some per the engineering work, the road network is supposed to pass a particular area. So when it happens that a rock, or a bed of rock, a bedrock is trapped in, or protrudes into the road path, then the engineers are likely to to break it up. Okay, so once that portion of the rock is blown away or is broken up, then it exposes the remains to further weathering. Okay, it exposes the remains or the remaining bedrock to further weathering. Is that okay? All right, so let's continue. Types of weathering. I hope you are all clear with all that we are doing so far. I believe you're all clear. All right, so let's look at the types of weathering. Types of weathering. Types of weathering. Now, there are basically two types of weathering. Okay, there are basically two types of weathering. Now, in some books or in some literature, you are likely to see three. Instead of two, you see three types of weathering. Okay, now they are not wrong. If you find it that way, the author or the person in charge of that book is not wrong at all. Just that the third one, you know, share the same process or mechanism, with one. So we are likely to combine the two to be one. Then the other is also standing on its own. That is how come we have two basically. So what are the types? What are the types of weathering that we have? What are the types of weathering? Now we are looking at physical or mechanical weathering. Physical or mechanical weathering. That's the first one. That's the first type of weathering. Then we will also consider the second one, as I said earlier, which has to do or which is chemical weathering. Chemical weathering. Chemical weathering. Now, the third one that you are likely to see in other books or in some literature has to do with what we call the biological weathering. Biological weathering. Now, we are likely to add the biological weathering to the physical or the mechanical weathering because the process involved in it, the process involved in the biological weathering, whereby plants' roots find their way into what rocks, breaking them apart. Activities of man, interfering with rocks leads to rocks being broken up. Then we have rodents, boring hole into what rocks. These processes are mechanical or physical in nature, even though they have a biological dimension. That is how come sometimes we add it to the physical or the mechanical weathering so that it becomes two. But if you find it in a literature, we have physical or mechanical weathering, then we have chemical weathering, and then we have biological weathering. That doesn't mean the person is wrong. So please take note, okay? All right. So we shall take them one by one. We shall first look at physical or mechanical weathering, and then we'll look at the processes involved, the various processes involved in the physical or mechanical weathering. So what is physical or mechanical weathering? One will ask, what is physical or mechanical weathering? Physical or mechanical weathering? Yes, can any of you try? physical or mechanical weathering, as the term goes. Physical, okay. Physical, mechanical, mechanical. Miriam, I can see Miriam there. Miriam, are you there? Miriam, if you are there, don't be shy, okay? Just unmute yourself and let me know you are there. Amu, Junu, are you there?
Yes, please.
Okay. I can't hear Miriam's voice. So is she there? Miriam, are you there? All right, so let's continue. I seem to be having difficulty hearing Miriam. So let's continue. Okay. So physical or mechanical weathering. Junu, you want to try? You want to give it a try? All right, so let's look at the physical or the mechanical weathering. Okay, physical or mechanical weathering. So basically what we are saying here is that physical or mechanical weathering simply refers to the breakup of rocks by physical or mechanical processes. Okay, or the breakup of rocks through physical or mechanical means. Is that okay? As simple as that. It's not so difficult to say. Okay, it's not difficult to say. Physical or mechanical weathering refers to the breakup of rocks by physical or mechanical processes. Okay, so our task here is to know, okay, the various processes involved. The various processes involved, okay, in physical or mechanical weathering. It is very, very important. Okay, we need to comprehend this aspect of this lesson very, very well. The processes involved, okay, in physical or mechanical weathering. All right, so we'll take the first one. The first one, the first processes or the first process involved in physical or mechanical weathering, and we are talking about temperature changes. Temperature changes. Temperature changes. Temperature changes. Basically, we are talking about heating and cooling. Okay, heating at a point in time, and then at another point in time, we have cooling taking place. So temperature changes, rise and fall in temperature. All right. Now, what are we basically? What are the issues here? Now, this type of or this process of mechanical weathering usually takes place in arid or hot regions. Okay, arid or hot regions, arid or hot regions of the world. So basically, we are talking about the deserts. Okay, the deserts, perhaps the equatorial regions where we have massive or huge dryness. Okay, as a result of high temperature. Is that okay? So this process of weathering is likely to take place. Okay, and mind you, this is under physical or mechanical weathering. Temperature changes or heating and cooling is a physical or mechanical weathering process. Is that okay? So you have to take note. Now, how does it occur or how does it happen? Now, during the day, okay, usually in arid regions or hot deserts. Have you done anything on deserts? Desert landforms? Deserts. So can you guys give me an example of a desert region in Africa. Desert region in Africa. Yes, who try? I've asked a question. Yes, I can see 2 hands up. Miriam, yes, you are there.
Sahara Desert.
Sahara Desert. Okay, Sahara Desert, basically located between northwestern Africa. Okay, northwestern Africa, and then perhaps southern. Okay, the southern part of the West African region. Is that okay? That is where we have. We basically have the Sahara Desert being located. All right, Miriam, your hand is still up. Miriam,
Okay.
your hand is still up.
Please, yeah, when I answered the question, that was when I raised my.
Oh, okay. All right. Emmanuel, you raise up your hand.
So yes,
Yes, you want to ask a
I
question?
wanted to say the same things.
Oh, okay.
No. I wanted to say the same thing. Savannah Desert.
Oh, okay. Okay. We don't have Savannah Desert. We have Sahara Desert, not Savannah. So take notes. Okay.
Okay.
So what are we saying? We are saying temperature changes. Okay, heating and cooling during the day. During the day,
Okay now.
during the day, when there is a sharp increase in temperature, okay, when there is a massive increase in temperature, rising dramatically, okay, from 36 degree, 38, 40, 41, 42, 43, 48 before it rise, it's getting to 50 degrees, okay. Such a sharp increase in temperature, okay, causes the rocks in these regions that are exposed to this huge or high temperature to expand once they are heated up. Okay, so once the rocks becomes heated up as a result of high temperature, they begin to what, to expand. Okay, in structure. Okay, they begin to expand. The person giving us a feedback should kindly mute his, or please, if you are giving us, if you know you are giving us, or if you notice your button is not on mute, kindly mute yourself and let's continue. You are giving us a very terrible feedback. All right. So as I was saying, the increase in temperature causes the rock that has been exposed, okay, to this high temperature to expand, okay, to expand. Once it gets heated up, once the rock becomes heated, it expands. And this takes place during the day where we have massive sunshine, okay, where we have massive sunshine giving rise to what? High temperatures. So this will cause the rock being exposed to the blazing sun to what? To heat up, and then for that matter, expands. Now, when we get to the evening, whereby we don't have sunshine, or we don't have sunshine, manifesting, then we are expecting temperatures to what? This time around, not to increase, but drop dramatically. Okay. So once temperatures drop dramatically, or once there's a decrease in temperature, okay, the initial rock, which has been what? Heated up and then expanded, this time around will now cool. Okay. It will now start cooling, because it is not having enough temperature anymore to continue heating up. So this time around, it will cool. So once the cooling is taking place, the rock then begins to what? To contract. Okay, the rock then begins to what? To contract. So the increase in temperature will cause the rock to what? To heat up and expand. Whilst in the evening, when there's a fall in temperature, the rock begins what? To cool down, and for that matter, contract. So when this process, okay, when this repeated process of heating up, expansion, and then cooling, contraction. I'll take that again. Heating up, leading to what? Expansion, and then cooling up or cooling down, leading to construction. Takes place repeatedly over a number of times. Okay, this is not something that happens within just a week. No, for an appreciable period. This will eventually cause the outer layers, the outer layers of the rock that is exposed to the heating and cooling, the expansion and then the contraction to eventually break up. So with time, you will see cracks developing around the outer layers of the rock, and this will cause it to break up over time. Is that okay? All right. So the breakup can actually take a number of forms. The outer layers of the rock, as it's being broken up or being disintegrated, can take so many forms. The outer layer can be, once it has been exposed to this condition or this situation, it can be, we have what we call exfoliation. The surface layer will be peeled off, or will peeled off in an onion-like manner. So you see how an onion looks like. Onion has so many layers or shells. So you can move a shell after one another until you get to the innermost shell. So that is exactly what happens here. The outer layer of the rock, is being peeled off. It's possible to be removed, disintegrated, or broken, in an onion-like manner. So that is that. Then the rock can also break apart, break apart into two or perhaps into three, not moving away, but at the same place. Once they are being broken, they'll remain at the same place, visible. You can see it. Is that okay? All right. So they can break apart. Then also we have what we call shattering. 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 The rock to shatter. More of bursting. More of bursting. Perhaps if you have a grain of maize, or yes, let me use a grain of maize or beans, and you throw it. Yeah. So that is the form in which the rock is also likely to break apart. So it can peel off, in an onion-like manner. It can break apart into two or more pieces. Then it can also shatter, what you call shattering, mechanical shattering. More of a blasting. It is possible. Is that okay? So these are the basically three forms in which the rock can break up once it's been exposed to this process of heating and cooling. And I hope you are all following. Now, as I said earlier, when the rock, you need to take note of these few things. When the rock is being exposed, we are still on temperature changes. When the rock is being exposed and it is being peeled off in an onion-like manner, the rock fragments, that has been peeled off, normally geographically, we have a term for it. Geographically, we have a term for it. Now, we may call them talus, or what you call screeds. Talus or screeds. These are the materials that are being broken. They are not transported away. They are not eroded away. They are remaining there, so it's visible. They are remaining at the station or at the point where they have been weathered. So we refer to them as what? The remains, the particles that are being broken up, we refer to them as what? The talus or the screeds. All right. Now, after the outer layer of the rock has been peeled off, what is remaining? What is visible? It's what we call an exfoliated dome. We call that an exfoliated dome. The process itself is called exfoliation. EXFOLIATION. Or what others will call spalling. 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 I hope you are following. So once the broken portion of the rock, the bedrock has been removed, then it is exposing a fresh outer layer, which will also undergo this repeated process. Which will also undergo this repeated process. So after some time, the outer layer will expand, contract for some time, and then peel off again. Then another fresh layer will be exposed, okay, to undergo the same condition. So that is basically what takes place when we are talking about temperature changes. I believe you're all following. All right. So we can continue. We can continue. Let's look at the second type of, or the second process of mechanical or physical weathering. That has to do with alternate wetting and drying. Alternate wetting and drying. All right. Now, this process of physical or mechanical weathering is also peculiar, or is also rampant in a particular geographical region. Okay, it is very, very prevalent in a particular geographic region. All right. So we are talking about perhaps humid, okay, or equatorial regions, humid or equatorial regions. The equatorial regions, we are referring to regions of the world that have high amount of rainfall. Okay, there's high rainfall. So if you are considering the equatorial regions of the world, we are talking about the Congo Basin, okay, the Congo Basin area, the West African area, the Amazon regions of the world. These are all equatorial regions, okay, where we have massive rainfall. All right. So when um, when we have a precipitation phenomenon, or we have a rainfall phenomenon, okay, what basically happens here is that the rocks in that region or in that environment will tend to absorb, okay, will tend to absorb the water, the rainwater, as it rains. Are you okay? Mind you, don't forget about the characteristics of the various rocks. Okay, rocks differ in terms of characteristics, their chemical composition, and then their ability to absorb water. Okay, their permeability, whether water can easily penetrate through them or not. Don't forget about all this. Is that okay? So once there is rainfall, the rock will absorb the water, okay, the rain. So once it's absorbed the rainwater or the water, what happens is that it becomes swollen, okay? It becomes swollen. So I just want you to just imagine or picture what I'm saying, okay? All right. Let me see, what example can I give you? Yes, some sedimentary rocks, basically, okay, you know, sedimentary rocks can absorb water uh, uh, um, more than metamorphic or igneous rocks. Okay, so once the rock absorbs the water, it's what it's it gets swollen up. That is what basically happens. So after the rain event, after the rainstorm event or the precipitation phenomenon, what happens? The rain stops. So we have a clear atmosphere, a clear weather, perhaps sunshine. So the rock then is now exposed to what? Dryness. So what happens? Once it's undergoes drying, okay, the water hot comes out within from the rock. What happens this time around? This time around, the rock will now contract. Okay, it will now contract. First, when it is being wetted, what happens is that it swells up. But once the water gets or is out of the rock as a result of dryness, it contracts. So when this process, okay, occurs repeatedly, take note of this process, okay. They should occur repeatedly over time, not just a one phenomenon or one-time event. They should be able to occur over a an appreciable period of time before the rock can eventually break up, or before the rock can eventually be disintegrated. So when we have this repeated action of wetting and drying, okay, leading to what? The rocks getting swollen, and then sometimes as a result of dryness getting contracted, then the rock will eventually what? Break up. The rock will eventually break down. So that is basically about the alternate wetting and then drying. All right. I have a picture of let me take you to the temperature changes whereby I talk about exfoliation. I hope you can all see your screen. So heating and cooling. This is the exfoliation I was explaining earlier, okay? Whereby you have the rock layer or the bedrock being broken, the surface layers being removed or be disintegrated in an onion-like manner. So let's take the first one. Look at the where I'm pointing the mouse pointer, where the mouse pointer is, this particular image. Okay, so this is the bedrock, this is the rock. You can see this portion, okay, is more of like a layer and is being peeled off. This area has also been peeled off. You can see this region. Look at the mouse pointer, also peeled off. Yeah, this side has also been peeled off, leaving this side, okay, also likely to be peeled off. Now, the materials are all over, they are around the bedrock here. They are not transported anywhere, as you can see. Look at where the mouse pointer is. There's one there, there's another one there, then there is one here, there is also one here, okay. So this is the exfoliation or the spalling we are talking about. Is that okay? Exfoliation or spalling. This is what we mean by exfoliation. As a result of heating and cooling, temperature changes. Okay, so this is how basically the rock eventually breaks up. Okay, all right. Then let's consider the second image. Let's consider the second image. You can see portions of the rock being peeled off. Okay, being removed, exposing new layers. Okay, exposing new layers. So that is the exfoliation. That is basically the exfoliation we are talking about. All right. So I've explained the alternate wetting and drying. Let's go to frost action. Let's go to frost action. Let's go to frost action. Okay. Are you clear? Do you have any question? Are you clear with what we are doing? How far we've come? All right. Okay, so let's consider the third process of physical or mechanical weathering. That is frost action. Frost action. Now, that term alone, frost action, frost, okay, has to do with something that gets frozen, okay. The ability of something to freeze up or to get frozen. So frost, okay, frost action. Now, this particular process of physical mechanical weathering prevails or is prevalent in regions where we have relatively lower temperatures, okay, low temperatures. So we are talking about the polar regions, okay, the polar regions of the world. And what we mean by the polar regions of the world, we are talking about the extreme northern hemisphere, okay, the Alaska regions, the North America, the extreme North America, the northern Russia, okay, areas of the world that are closer to the poles, okay, that are closer to the poles, both the North Pole and then the South Pole, okay, and then perhaps on high mountains, okay, on top of high mountains, whereby temperature decreases or falls dramatically, which has the potential to cause water that is collected within cracks of rocks to freeze up. Okay, so these are basically the areas or the regions of the world that we have the frost action process taking place. Is that okay? So what then happens? What actually happens? Now, during a precipitation phenomenon, a rainfall, perhaps when there are cracks, okay, when there are cracks that develop within the bedrock and water finds its way into these cracks within the bedrock, as a result of a massive fall or a decrease in temperature, the water collected within the cracks, okay, in the bedrock then becomes to freeze up or it becomes frozen, okay. And believe me, once freezing takes place, okay, there is expansion, okay. Once there is freezing, once the water collected in the cracks of the rock freezes or gets frozen, it expands. There is expansion. Is that okay? And this is as a result of a fall in temperature or a decrease in temperature, okay, which will cause the water collected within the cracks, okay, in the rock. Yes, I see Bisa Nana Kofi, your hand is up.
Yes, please. You see, when the water is collected into the rock, it begins to freeze, and
Yes.
freezing causes expansion.
Yes, it's the freezing that causes expansion, okay, within the crack.
But I'm saying, isn't all freezing causes contraction and then heating causes expansion?
No. This time around, we are not talking about temperature changes, okay? Or we are not talking about temperature. We are talking about extremely cold, okay, areas, okay? We are talking about extremely cold or colder regions, okay? Whereby,
Okay.
yes, yeah. So this is basic science. Don't forget some of the concept or the ideas you learn in your other disciplines as well, okay? When there is freezing, okay, there is expansion, okay? So perhaps you can experiment. You can experiment this in your house. You put a cup of water. Yes, so you put a cup of water, perhaps a plastic one, of course, and you put it in a fridge. Okay, allow it to freeze up and see what happens. See whether there will not be some form of expansion. Is that okay? All right.
Okay. All right. Thank you.
All right. All right. I think I could finish this. Okay. Yes, can I wrap up with them? Let me just wrap up, please. I'll wrap up there now. What? Okay, so let's continue. Okay, so once the water collected, okay, within the cracks of the rock gets frozen, what happens is that there is expansion, and once there is expansion, okay, the crack begins to deepen or to widen, okay, and the widening of the crack is as a result of the expansion, okay, of the water that is collected within the crack. Okay, so once it freezes, it causes it to expand, and therefore the crack, okay, continues to widen. All right. So yes, temperature may change. Okay, temperature may change. Perhaps we may have a relatively, you know, slight increments in temperature that will cause the water, okay, this time the water collected in the rock, okay, the crack within the rock to melt up. So when temperature increases, then the water collected in the crack, okay, within the rock, this time around begins to melt. Okay, so once there is melting taking place, it means there is construction. Okay, the outer layers of the frozen, okay, water is no longer having contact with the edges of, okay, of the crack. So there's some form of contraction. So some form, let's assume closing. Okay, the cracks begin to somehow close up. So when this happens, okay, and this should also be a repeated, you know, action. It should be a repeated process. It should not be something that happens maybe for a week or days. Okay, it should happen for some appreciable, okay, period of time. So when this process takes place over an appreciable period of time, okay, water collected within these cracks freezes up, it expands and then deepens the crack. It melts and then contracts. Another time, it collects again, freezes up, and then what? It contracts, deepens the crack further. Then in other circumstances, then it melts, okay, and then for that matter, causing it to contract. When this happens over and over again, okay, when this happens over and over again, then the crack within the rock begins to deepen, okay, and once it deepens, it continues deepening. A time will come whereby it will eventually, you know, break apart. A time will come where it will eventually break apart. So this is basically about the frost action. Okay, you are not likely to see a frost action, okay, process of weathering physical or mechanical weathering taking place in a desert area. No. Okay, no, it cannot happen. All right. So I'll show you an image that has to do with the frost action. Let me see whether it is there. Yeah. Yeah. So this is basically what I'm talking about. Okay. So initially, look at where the mouse pointer is. Okay. Let's continue. We are done with the processes involved in physical or mechanical weathering. So we'll proceed and look at the processes involved in chemical weathering. So they will proceed to look at chemical weathering and then the processes involved in chemical weathering. All right. So one will ask, what is chemical weathering? One will ask, what is chemical weathering? Chemical weathering. Chemical weathering. So basically, we are talking about the gradual disintegration or break up of rocks due to their exposure to air and water. Chemical weathering can be explained as the gradual disintegration or breakup of rocks due to their exposure to air and water. So air and water is very, very important. When you consider air and water, they are very, very important or crucial in the process of what? Chemical weathering. For chemical weathering to take place, then the rocks exposure to air is very important. At the same time, their exposure to water is also very, very important. All right. We sometimes refer to chemical weathering, the process of chemical weathering. We sometimes refer to this as rock decomposition. Rock decomposition. So instead of hearing chemical weathering, you could also hear the term rock decomposition. So when you mention rock decomposition, basically we are referring to what? Chemical weathering. We are referring to chemical weathering. So take note. Now, this process of chemical weathering, the chemical weathering processes are common in hot, wet climates. Okay, hot, wet climates or humid regions of the world with high temperatures and an abundant water. Emmanuel, your hand is up. Emmanuel, I see your hand up.
So people are chatting during the lesson, so sir, can you please tell them to stop?
Yes, I think that has been done. So we are not having any feedback now. We are not having any feedback. Or do you have any feedback there at your end? All right, so let's continue.
So a lot, about 16 chats.
Really?
About 16 chats.
No, but on and off, on and off. All right. So guys, let's continue. All right, let's continue. So sometimes chemical weathering can be referred to as rock decomposition. Rock decomposition. And we said this process of chemical weathering occurs usually in hot, wet climates where there is abundant water. Okay, when there is abundant water, and then the temperature is very, very high enough. The temperature is also high to allow the decomposition process to occur. All right. I want you to note this. Note this. Chemical weathering. The chemical weathering process transforms rocks and then the minerals that are exposed to water and then air into a new chemical product. So take note. Unlike in the processes involved in physical or mechanical weathering, where the chemical composition, the structure, and perhaps the appearance of the rock has not been tampered with, when we are under the chemical or rock decomposition, the rocks are transformed. The minerals in the rocks that are exposed to water and air are transformed completely into a new chemical product. So we have end products of these processes that occur. We have end products of these processes that occur. So take note, very, very important. All right, so we'll continue. Are you okay? Are you all okay with the explanation and the chemical weathering?
So please come again.
I'm asking whether you are okay with the processes involved, the chemical weathering process, the explanation and the chemical weathering. Are you okay?
Yes, sir.
Or you want me to go over again? I'm asking the whole class.
Sir.
Will you like me to go over again?
Yes, please go over.
Say yes.
Go over.
All right. All right. Then mute yourself so that we can continue. Mute yourselves. Mute yourself so that we can continue.
Yes.
All right. So
Yes.
we've moved from the processes involved in physical or mechanical weathering. We've moved away. So I believe you can all hear me now. We're having network challenges, so please kindly bear with me. Okay. All right. So we are looking at chemical weathering. We are looking at chemical weathering. So we say chemical weathering is the gradual disintegration or breakup of rocks due to their exposure to air and water. Due to their exposure to air and water. Now, this process of chemical weathering can sometimes be referred to as rock decomposition. Rock decomposition. So chemical weathering is also referred to as rock decomposition. That is why in your definition of weathering, if you remember quite well, we said it is the physical disintegration and then the chemical decomposition of rocks in situ. The physical breakup and then the chemical decomposition of rocks in situ. That was the definition we gave for weathering. So we are looking at chemical weathering. Chemical weathering. We are saying the chemical weathering can sometimes be referred to as rock decomposition. All right. Now, this process of chemical weathering, the chemical weathering processes are usually common in hot, wet climates. Hot, wet climates or humid regions of the world with high temperature and then abundant water. Areas of the world where there is adequate.
Oh, but I've stopped. I've stopped.
So what is Nana? Follow Nana.
Oh, I want to ask him a question.
Ask him privately after class. Right now we are learning.
It's about a class, so it's about a class.
Hey guys, we pay for data. We paid for this. Please show some, respect on the platform and stop talking.
All right, let's continue. So in regions where there is abundant water supply, there is abundant water supply, and then high temperature, and then high temperature. Then we have the process of chemical weathering taking place in these regions. We have the chemical weathering processes occurring in these regions. And then I ask you to note a point here. I ask you to note a point here that in the event of chemical weathering, during chemical weathering processes, the rocks are transformed. The minerals within the rocks are transformed once they are exposed to water and air. So their exposure to water and air transforms the rock into a new chemical product, into an entirely different chemical product. Is that clear? Unlike the physical or mechanical weathering processes, whereby in the course of the breakdown, the processes leading to the eventual breakdown of the rock does not affect or change the chemical composition of the rock. The texture or the appearance of the rock does not change. Neither is the structure of the rock changed. But when we are dealing or when we are experiencing a chemical weathering process, what happens is that the entire structure of the rock, the minerals present in the rock, as they are exposed to water and air, changes into what? An entirely new chemical product. So that is the point I want you to note here. All right. Now, what are the conditions necessary for chemical weathering to occur? What are the conditions necessary for chemical weathering to occur? We'll look at three of them. We'll look at three of these conditions. Now, the first one has to do with the fact that there should be abundant water. There should be abundant water in the air or the ground surface. There should be abundant water in the air or the ground surface. Very, very important. Okay, because the ions or the minerals within the rock, it is as a result of their exposure to this air that is what leads to what their eventual breakup. So there should be abundant water. There should be abundant water in the air and then the ground surface so that this rock can react. Okay, they can, once they are exposed to this water, it will react. It will react with the water to cause the eventual breakdown of the rocks. Now, the second condition is about oxygen. So there should also be enough oxygen in the air or the environment. There should be enough oxygen in the air or the environment. And this is very, very, very important, particularly with regards to the disintegration of rocks as a result of oxygen. When there is oxygen in the air, and then minerals within the rock, such as iron. When minerals within the rock, such as iron, when they are exposed or when they come into contact with oxygen, this will cause the rock to eventually break up. This will cause the rock to eventually break up. So the presence of oxygen in the environment or in the air is very, very important for a chemical weathering process to occur or take place. Then also, in some instances, we may need enough carbon dioxide. Okay, there should be enough or presence of carbon dioxide to also spearhead or fast track the process of chemical weathering in these regions. All right, so we'll proceed. We'll proceed to look at the processes involved in chemical weathering. The processes involved in chemical weathering. Is that clear? What are the various processes involved? Yes, Pearl, your hand is up.
Yes, sir. Sir,
Yes.
sir, we want to ask that the things, the conditions, can we say, can we give an example by saying when you go to the seashore, sometimes the rocks there disintegrate. So can we say they are also some of the necessary conditions?
I didn't hear your initial statement as you began your question. I didn't hear the early part. So come again.
Sir, please, I'm
Yes.
saying that pertaining to the conditions necessary for chemical weathering,
Yes.
sir, can we say in an example that for when you go to the seashore,
Yes. Coastal areas.
the seashore,
Okay.
can we, yes, sir, can we say during the when we are at the seashore, do we have some of this how do I say it, rock distinguishing there?
Yes. Yes. It is possible because when you get to the coastal areas or the coastal regions, you know, the amount of water there is huge enough. Okay. Okay. The presence of water in these coastal regions or coastal areas are enough to allow the decomposition of rocks to take place or to occur. So you are right. Okay.
Okay, sir.
All
Thank
right.
you.
All right. So let's look at the various processes involved under chemical weathering. So basically, we'll look at 5 processes. We shall look at 5 processes under chemical weathering. 5 processes. The first one is solution. The second one is oxidation. The third one is carbonation. The fourth one is hydration. Then the last but not least is hydrolysis. Hydrolysis. Let me be quick to mention that hydrolysis is the most important chemical weathering process. When you are looking at chemical weathering, hydrolysis is the most important process of chemical weathering. So you need to take note. All right. Now, I will require you to bring on board your knowledge in chemistry. Your knowledge in chemistry here, perhaps interscience will help so that we can comprehend some of these concepts, because there are cases whereby chemical reactions will be taking place. Okay, chemical reactions, you know, will be taking place, leading to what? The eventual breakdown of rocks. There are instances whereby rocks will completely dissolve in water. Rocks will completely dissolve in water. Pearl, your hand is up.
Sorry to say it's a mistake. Sorry.
Okay. So we'll look at these processes. Our time is up. Our time is up. So our network is not so favorable today. We have a lot of challenges today. So we'll bring the class to an end here. Hopefully next week when we meet, we shall take the processes one by one, one after the other. Okay, and explain them into detail. Divine, your hand is up.
Yes, sir. Sir, please can you send the slides to the Google Classroom on the previous lessons?
Yes, I'll do that.
Okay. Thank you.
I said at the beginning of the class that I will be doing that.
Okay, sir.
And also I think I've sent you an assignment. So those of you who are yet to visit the Google Classroom, there's an assignment awaiting you there. I've sent you an assignment, and then the details are there. So that is a quick information. So when we meet next week, God willing, we shall look at the processes, these various processes listed here. We'll take them one by one and then explain them. So you can also go and then read in advance, try and read on all these processes so that when you come to the class, we'll be able to to move smoothly. We'll be able to move smoothly. Do you have any question before we end the lesson for today? If you have any question, you can ask so that we can end the lesson for today. Do you have any question? Do you have any question?
Sir, please, no.
Okay.
No, sir.
All right. Then I'll see you next week, God willing. Okay. Make sure you do. Make sure you do the assignment and then submit it on time. The time is also there. All right. Bye bye.